Okay, so now I'm recording already. I'm start recording already. Yeah. So all right. Okay, I'm recording. Okay. So what I'm going to learn about the second part. Yeah. So first law of thermodynamics. Okay. Before that, okay. So first law of thermodynamics. All right. So state the first law of thermodynamics. Yeah, delta U equal to Q minus W. What is mean by this equation? Okay, this equation actually is first law of thermodynamics. Yeah, delta U equal to Q minus W is actually first law of thermodynamics. Okay, and then we need to solve some problem related to this equation, related to this first law of thermodynamics. Thermodynamics is the study of how energy can be exchanged between a system and its surrounding. Any system can exchange energy with its surrounding with two general ways, as heat or work. Heat is Q lah. Q is the heat. Work is W. Okay. This will affect the macroscopic properties of the system, like pressure, volume, and temperature. Do you remember your tutorial book? Do you see this picture? Did you see this picture? Where is it? See this picture? Yeah, where is it? You see this picture? Did you see this picture, class? What is this? Air condition, right? Aircon. How do aircon function? It's all because of what? It's all because of first law of thermodynamics. This is the air condition. So first law of thermodynamics. So that means that this system can exchange energy with surrounding, such as heat and work done. For example, I show you, aircon, So how do aircon function? Aircon. This is the room. Okay. This is the room. So this is my aircon over here. Air condition. Aircon. Yeah. There outside there is a compressor, isn't it, class? There is a compressor. Compressor to change the pressure of the gas somehow. So actually the function of aircon. Do you know how to make the room? Initially the room is very hot. Initially the room is very hot. The temperature is very high. Temperature is very high. So do you know how to lower down the temperature in the room? How to lower down the temperature in the room? We know that this temperature, you learn about temperature of the gas. This is actually temperature of the gas inside the room, right? Temperature of gas inside room. Temperature of gas inside room. Do you remember the kinetic theory of gas? Kinetic theory of gas? You learn this internal energy of gas, right, not class? You learn about what? You learn internal energy of gas, and internal energy of gas is related to temperature. Okay. Let me write something over here. So inside the room, this is the room. This is the room. So inside the room has gas lah, has gas around us. So inside that, that means just put it inside of inside the room has gas. The gas has internal energy, and we know that internal energy of gas is the total kinetic energy of gas, isn't it? And what's the formula, class? What's the formula again? 1/2 F and KT, or F and RT, right? Not? That's the formula, 1/2 F and KT. That's the internal energy of gas. Okay, so that means inside the room there has many air particles, air particles moving around, and all this air particle has kinetic energy. It has kinetic energy, so it has internal energy, right? Internal energy. Okay, so and they have their own speed lah. Yeah, they have their own speed. We have an useful average speed value we call root mean square speed. We also have a formula for the root mean square speed, which is 3kt over small m. Correct or not, class? So that means they have kinetic energy. These gas particle, they all have kinetic energy. They have speed, and this kinetic energy is the internal energy of gas. Yeah, internal energy of gas. And this internal energy is related to their temperature. It's related to their temperature. Understand? So how to make the room cold? What do you think, class? How to make the room cold? How to make the room cold? Of course, I need to lower down this. I need to lower down this internal energy of gas. Okay. Let me write it beside. U is what? Internal energy of gas. So how to make the room cold, class? How to make the room cold? How to make the room cold? I need to lower down the internal energy of gas, isn't it, class? I need to lower it down. I need to lower it down. That means when I lower down the internal energy of gas, I actually lower down the kinetic energy of gas. And when I lower down the kinetic energy of gas, it lower down the temperature. It also lower down the root mean square speed of the gas. Because when the speed is lower down, that means the temperature is lower down. So how do I achieve this? How do I lower down the internal energy of gas? How do I lower down? That means I must take energy out. That's a function of the aircon. I must take the energy out, isn't it, class? I must take the energy out. How do energy is being taken out from the internal energy of gas? How to take out the energy? How to take out the energy? That means energy must exit from the room. The energy must exit from the room in the form of heat. Understand or not? That's why the notes is say here, thermodynamic, class. Thermodynamic. A system exchange energy with surrounding with two general ways such as heat or work. Have you gone to the... Don't say about aircon. Just talk about our refrigerator. Do you have refrigerator at home, class? Your fridge, class. Your fridge. Do you have a fridge at home, or you don't use fridge? Yeah. Do you use a fridge before? Don't ask the silly question. Do you go behind the fridge, class? Behind the fridge. Okay. Let's say this is behind the fridge. Yeah. Behind the fridge. Yeah. Behind the fridge. There, behind the fridge, there's a compressor, isn't it, class? Do you know a compressor there? Do you go behind the fridge before? You feel inside. You feel inside is cold, but you feel here is hot. You feel behind here is hot, isn't it, class? You feel outside here is hot. Same also for aircon. You feel at the compressor there, you feel is hot. Do you know why it's hot? Inside is cold. Do you know why it's become cold there? Why is it become cold? Yeah. That means temperature can be lower down. Yeah, temperature can be lower down. Yeah. But you know outside it become hot. You know why temperature outside become hot when inside become cold? Because the function of the aircon is to take the energy out from the room. It must take energy out from the room in the form of heat. I don't want to say how the aircon works. We know that it takes the energy out through the compressor. How it takes is like evaporation of the liquid, and then it absorbs heat energy, and then turn to condensation back, absorb all the heat back like that. So you Google search how the aircon works actually, how the compressor works. Generally is aircon is just to take the energy out from the room in the form of heat. So that the internal energy of gas inside the room will decrease. End up the kinetic energy of gas will decrease. So the temperature of the gas inside the room will decrease. So that's why it becomes cold. And outside, when the heat is being taken out, so we can feel at the compressor there is hot because heat energy is being taken out from the room. And over here we feel is hotter, the temperature here is higher. Same goes to the fridge. You know how the compressor in the fridge, how is it work? It also, inside there is a gas. Inside the fridge, there's a gas, but of course everywhere is gas, right? Gas particle. But the gas has internal energy. So the compressor is to take the energy out from the fridge in the form of heat. So what happened is the internal energy of the gas inside the fridge will decrease. So the temperature also will decrease. So it become cold inside. Outside, when the heat is taken out, you go behind the fridge, you feel it's hot. Understand? I know some of you make innovations like we don't say, oh, how do we make the room cold? Some of you make portable aircon. That means you bring ice into the room, and you thought that you bring coldness into the room. You bring coldness into the room. You bring a lot of ice into the room, and you bring coldness into the room. No, that's not how it works. We cannot bring coldness into the room. There's no such thing as bring coldness into the room, bring ice into the room. No, that's not how it works. Aircon it takes energy out from the room. It's not bring coldness into the room. Understand? It's actually we absorb the energy from inside the room, exit the room in the form of heat. There's no such thing as bring coldness, bring ice into the room. Even you bring ice in the room, actually the ice is absorb heat. Understand? Absorb heat and then it turn to liquid. When you absorb heat from inside the room, of course the internal energy of the gas will decrease because heat is absorbed into the ice. So when internal energy of the gas decrease, temperature of the gas decrease. That's how the room get cold. Okay, no such thing as bring coldness into somewhere. Understand, class? So aircon is to absorb the heat out. That's all, That's what's the how the aircon works. Okay, you can Google search for more. All right. So in today we're going to learn about the first law of thermodynamics, which is this formula: delta U equal to Q minus W. Okay, heat. Aircon is it bring the energy out in the form of heat. Energy can exceed the room in the form of heat. It also energy can exceed the room in another form, which is energy can exceed the room in the form of work done. That means if this room able to do some work, energy of the internal energy of gas also will decrease. This work done is for other system lah. So that one also I will discuss. Okay. So internal energy of gas can change in two ways, either by heat or work done. Okay, I will explain both. Okay, and this will affect the macroscopic properties like pressure, volume, and temperature. Like the aircon room, the temperature will change. Pressure and volume also will change. You know why will change? Because all is affected when temperature decrease. That means all, you see, PV equal to nRT. Understand? PV equal to nRT. So when temperature decrease, all this also affected. Temperature, pressure, and volume is affected by temperature also. You know, pressure and volume also affected by temperature. So it affect all these, you know, this pressure. Oh, sorry. This pressure, volume, temperature, all these are called the macroscopic property. Why we say macroscopic? Because it's something we can see, something we can really feel it in macroscopically. Yeah, we can measure the change of pressure, change of volume, change of temperature. It's something we can really feel. Yeah, not microscopic, it's macroscopic lah. Something big, yeah, something big changes happening. Okay, take the heat energy out as in the form of heat, so the internal energy of gas will decrease, temperature will decrease. We will explain more about that later. Okay, so PV equal to nRT, remember? So involve pressure, volume, temperature. So this formula, class, first law of thermodynamics says that the internal energy of the system changes from initial internal energy value to final internal energy value due to heat loss or heat absorbed and work done on the system or work done by the system. Delta U equal to Q minus W. So all these changes of energy in the form of heat and work done all will affect the changes of internal energy of gas inside a room or inside a container. We actually focus on changes of internal energy of gas inside a room or a container. Okay. So okay, continue. So change in internal energy of gas. And change of internal energy, that means when we talk about change of internal energy, that means internal energy changes. That means got initial and final value. So to find the change in internal energy, we always take final internal energy minus initial internal energy. Okay. Q is heat added into the system or heat loss from the system. So this heat can be heat added or heat loss. Work done by the system or work done on the system. So this W is work done. Okay. About work done, I will explain more later. Yeah. This is the most important. Sign convention. You must learn this. You must learn this. If you want to next time you want to manufacture aircon, fridge. You must learn thermodynamics lah. Then only you know the physics principle. Understand? So sign convention of so Q, all these delta U, Q, and W, they all have positive and negative value. You will have positive delta U, we have negative delta U, we have positive Q, we have negative Q, we have positive W, we have negative W. Okay, class, about this equation, if you look at my previous YouTube video, my old YouTube video, the equation a bit different. If you notice, my equation last time is Q equal to delta U plus W. But it's the same, class. It's the same. New syllabus use this formula, delta U equal to Q minus W. If you see, it's actually the same as this formula, because if I exchange the W behind delta U, okay, so when W go to the other side, it become negative. So it become Q minus W. It's the same, isn't it? Class, it's the same, right? See? Delta U equal to Q minus W. Delta U equal to Q minus W. It's the same. So my old YouTube videos, I use this formula because old syllabus use the first formula. The new syllabus, you have to use the second formula, the new syllabus. So that's why the lecture note changed already. We use the new formula. Please, I advise you use the new formula. Don't use the old formula lah. My old YouTube videos use the old formula, but I advise you use the new formula. Okay, but what I can say is both formula is the same. Yeah, But because of new syllabus, I want you to use the new formula. Okay, delta U equal to Q minus W. Okay, so about the positive negative sign, it's the same lah. Before and after is the same. Old and new is the same. Yeah. When is it positive? When is it negative? It's the same. Yeah. No changes at all. Okay. Now I want to explain one by one. Q. When is it positive? When should you put positive Q value? When you put positive Q when heat absorb into the system. Like you see this one. This one, let's say this is the system, or we can say this is the container lah. This is the system, or this is the room. This is the fridge. Inside the fridge. When heat go into the fridge or heat go into the room, that one is positive Q. Understand? Heat absorb. That means when heat absorb, of course, the room become hotter. Correct or not, class? Give me a thumbs up if you understand. Okay. You assume that this system is like your room. Your room. You can say your dorm lah. Your dorm got aircon not? No aircon lah. Okay, never mind. Yeah. Okay. I also know aircon actually in my own home. Yeah. Only my master room got aircon. Yeah. Okay. This is your room. Okay. If heat go into the room, you feel hot, right? So if heat absorb into the system, into your room, you put positive Q. The Q heat, the system or the room absorb heat. Heat flow into the room. So it's positive Q. Okay. If heat loss, like the aircon, if aircon take out the heat, right? Aircon take out the heat from the room feel cold. If heat is flow out from the system, flow out from your room, flow out from your refrigerator, that means the Q you put negative value. Then your room will feel cold. Understand? When heat is heat flow out from the room, you feel cold because because the internal, when the heat is flow out, the internal energy inside the room decrease. You feel colder temperature. Got formula 1, you see. Internal energy equal to half F NKT. Got formula 1. That's why you learn physics. You learn how to calculate everything quantitatively. That's the wonderful of physics. Okay. So, heat flow out from the system. So that's okay. You feel cold when heat is lost. Now change of internal energy, delta U. So if internal energy means your room lah, your room internal energy, your room, your internal energy of gas inside the room. If delta U is positive, that means the room become hotter. The internal energy of gas inside the room, U is inside the room. Internal energy. If internal energy inside the room increase, temperature increase lah. Imagine if heat flow into the system, of course delta U become positive. Delta U positive means internal energy increase, temperature increase. If heat flow out from the system, let's say heat flow out from the system, the internal energy will decrease. Internal energy will decrease, temperature will decrease. Delta U is negative. Delta U is negative if your internal energy decrease, temperature decrease. Understand, class? Give me a thumbs up if you understand. Good. Now, work done. Work done by system. This work done is not by aircon or fridge lah. Work done is more to piston. More to piston in the engine, in the car. Work done on the system. Okay. This work done. So just now we talked about heat. Actually, work done also can interrupt the internal energy of gas. Yeah, interrupt the internal energy of gas. Work done by the system. That means when you compress the air inside, if let's say this is the room, if you are able to compress the room from bigger volume become smaller volume, also will change the internal energy of gas. Yeah, it will disturb just like the heat. You see, if you, let's say like work done on the system, it's just like heat flow into the system. Work done on the system, that means you add energy into the internal energy of gas inside, so the temperature will increase. Okay. If work done by the system, that means energy flow out, just like the heat flow out from the system. Work done by the system. Work done by the system means expansion. So volume, this one volume increase lah, expansion. So this one also will cause the internal energy inside the system decrease. Yeah, just like heat flow out from the system. So heat add to the system is due to is used to change the internal energy of the system or do work on the gas system. Okay, let me explain. Let me explain this one more time. I better use OneNote lah, yeah, to explain better. Yeah, I always like OneNote explanation because explain better everything. Yeah. Okay, I think I also will not teach too much for today lah. Yeah, let you digest a little bit. Yeah, what we have learned today. Yeah. Okay, this is our system. Let's say our room lah. Yeah. Maybe I should put it over here. Okay. This is our how to say maybe I just put a container this time. Yeah. Maybe I just put a container. Just put a simple container, class. A simple container with the ability to expand and contract. With the ability to expand and contract. Okay. So class. Okay. So let me. Okay. Now class. So let's say heat absorb into the system, class. Heat absorb into the system. Heat absorb into the system. What is the sign of Q, class? What is the sign of Q? Tell me. Tell me what is the sign of Q? Heat absorb, heat go into the system. Someone tell me. Yeah? Anyone can open your mic and say something? Yeah? No one? Heat flow into the system, heat absorb is positive Q, isn't it, class? Positive, right? Okay, that means it's positive. Okay, look at the formula. I want you to look at the formula, class. Delta U equal to, what is the formula again? Q minus W, right? Q minus W. Okay. So when Q is positive, you see, if Q is positive, that means what? That means delta U also. That means, let's say I don't have the I rewrite the formula above. Yeah, delta U equal to Q minus W. Let's say we don't have the work done. We don't have the work done. Okay, just heat absorb. Heat absorb. So what will happen, class? Q is positive, right? So what will be the value of delta U? Positive also, isn't it, class? Positive, that means what? That means what? Delta U positive means what? Internal energy increase. Temperature will increase, isn't it? Internal energy increase, temperature increase. Correct or not? That means this the gas inside, the gas inside. Where's the gas inside? The gas here is the gas. Yeah, there is a gas inside. So what happened, class? So the internal energy will increase, temperature will increase. Understand, class? Heat absorb. Good. Yeah, good. So class, next now, let's say this time is heat exit. Heat exit. So Q is what? Heat loss from the system. Loss. This is the, we call this is the system, or this is the our room lah, our room, you know, our room that you stay right now, your dorm, you know. And this is the outside is the surrounding. Outside is the surrounding. Okay. Outside surrounding means outside the room lah. Now if heat is lost, use what sign, class? Heat loss negative, isn't it?
Negative.
Negative. Someone please say something. I don't want to be alone, you know. Does any one of you like to be alone? Lone Ranger? Nobody care about you? How do you feel? No friend? Nobody in a lone world? You like to be in that kind of world? How do you feel? So don't make me feel like that lah, yeah? No man is an island, right? So heat loss. So if heat loss, hold on a second. Yeah, disturbance everywhere. Someone drilling just beside. Yeah. Those of you who have class, you can go for your other class. I'm going to finish this a little bit while longer. Yeah. Don't worry, you can exit this Google Meet. Yeah, I still recording. Yeah. F13 can stay with me. If other class is still on stay, no problem. Okay. Now, heat loss. That means, look at the formula again, class. That means okay, this is I write over this one. All right, so this is our general formula, delta U, this one. Okay, and now what about delta U equal to Q? This time the heat exit. Heat exit means negative, isn't it, class? So what is my delta U, class? Tell me, what is the delta U now?
Negative.
Negative. Good. Thank you for being my friend. Yeah, I don't want to be alone. Yeah, thank you. So, so delta U is negative right now. That means what is mean by negative delta U? Negative delta U means internal energy decrease, temperature decrease. That means your internal energy will decrease, temperature decrease. Understand? Negative delta U negative means temperature, you know, internal energy decrease, temperature decrease. That means if heat is lost, this is what aircon do, class. This is what aircon do. It take the heat out. Outside you feel hotter lah. Surrounding you feel hotter, but inside the room you feel colder. Because why? Delta U negative. The internal energy decrease, temperature decrease. Understand not? So inside the room you feel cold already. The internal energy decrease, temperature decrease. Understand, class? Understand? Okay. Only Sufika is my friend. Ask me also. Yeah. Okay. Okay. Now, what else? Not just the heat. Heat is just one form. Work done also will cause changes in the internal energy of gas. Yeah, we know inside the room it has internal energy 1/2 F and KT. Yeah, internal energy of gas. One way is the heat absorb or heat loss. Yeah, it will change. It will affect. You know, internal energy affected by heat, exchange of heat, or work done by the gas. Heat is just a way. Work done is the other way. Understand? Okay, how about work done? How work done works? Same thing. How to work done? We have, you know. Okay, let me write something over here lah. Heat. This one is just now Q positive means heat absorb. Yeah, heat absorb. Heat absorb into the system. This one is heat loss to the surrounding. Yeah, Q negative. Now, work done. Okay, work done has two. Work done by the system, which is expansion. Work done on the system, which is compression. So what is mean by work done by system? Expansion. That means, let's say the room, the system do work. Work done by the system means who do work? The system do work. How the system do work? If the system able to, or the room able to expand, to push the piston up. Let's say it push the piston up. Yeah. Let me. Okay. Let's say you know the gas inside the room, inside the system has gas. Let's say the gas do work. The gas do work by pushing up the piston. This is the piston. Yeah? This is the piston. So he pushed up the piston. That means expansion. Isn't it, class? Become bigger volume. Become bigger volume. Expansion. Okay? Become bigger volume. So that means, what is it means? Okay, let me write it down. Okay, let me write it down. I need to make the writing bigger. Sorry. Okay, that means work. You see, work done. You surely not understand what is work done by system and work done on system, right or not? Let me explain. Yeah, what is mean by work done by system and work done on system. Okay, work done. I write it down first. Work done by system. Work done by system means system does. System does work. System does work. Which is also mean how the system does work, class. System pushes up the piston. When the piston is being pushed up, what happened, class? Yeah, it means expansion. Correct or not, class? That means this one is volume increases. Correct or not, class? Correct or not? Work done by system. But work done by system. So work done by system means who do the work? Who do the work? The system do the work. Right or not? The system do the work. How does the system do work? The system, that means the gas. Or in other words, we can say it is the gas who do the work. It is the system is the gas. The gas do the work. How does the gas do the work? The gas push up the piston. The gas push up the piston. Gas push up the piston. Expansion. It will cause expansion, volume increase. Okay, there's another term. What do we say? Work done on system, right or not, class? Work done on system. Let me write it down. So work done on system. If work done on system, that means work done on system. That means who do the work? Who do the work? That means human. I guess say human lah. Human do the work, not the system. Not the gas. It's human does the work. Okay, that means human pushes down. Because the gas can't push itself. Yeah, who pushed the piston? Let me see. Let's say who can push the piston down? Can the gas push itself? No, it must be the human outside, right? Human pushes down the piston. Human pushes down the system. Yeah, the gas cannot push down the piston. Yeah, the gas pushes down the piston. So this is work done on system or work done on gas. Work done on gas. Work done on gas. This one is called compression. Compression, that means volume decreases. Okay. So this is human does work. I can say human does work on gas, on system. Does work on system, or on we can say on gas. Sorry, let me make it bigger. Yeah, like that. Yeah. I think that's better. Okay, it does. So work done on system. Who do the work? Who do the work? Human. Okay. So work done on system, work done on the gas means must be human compress. Human can compress the gas, but gas can expand. Yeah, gas can push up the piston. Human can push down the piston. Understand? Human pushes down the piston. Excuse me. Okay. Human pushes down the piston. But sorry, just now got disturbance again. Human pushes down the piston, but gas pushes up the piston. When gas pushes up the piston, hold on a second, class. Sorry. Sorry, kejap call lah. Saya tengah mengajar. Nanti saya call balik. Okay. Sorry, so many disturbance. Yeah, I'm going to finish it in 10 minutes. Yeah. So, gas. Where am I? Okay. So, work done by gas. Yeah, work done by gas. How does the gas do work? The gas do the work by pushes up the piston. Yeah, when gas push up the piston, of course, expansion happen. Yeah, volume increase. Work done on system. Work done on system means human do the work. Yeah, human do the work on the gas. Human do the work on the system. How the human do work on system? How the human do the work done on system, on the gas? Human pushes down the piston. Human compress the gas. Understand? Human compress the gas. Volume of gas decrease. This one, gas expand. Gas expand. System does the work done by system. That means system. That means the gas expand, volume increase. Understand, class? Okay. Now, I'm so sorry. Okay. Now, look at here. Work done on gas. That means human pushes down the piston. Human compress the gas. I should add some more lah. I should add some more. Human compresses the gas. What will happen, class? And then this one is the gas expand. The gas expands by itself. Like that. Yeah, gas expands by itself because work done by gas. What? Work done by work done by system. Work done by gas. Okay. Compresses the gas, compresses the system. Is that clear enough, class? I think it's clear enough, right? Okay. Now, if you compress the gas, you are adding energy into the system. You are actually like heat absorbed, class. So this is work done on gas. That means, where is it? Work done on gas. On the system. Work done on the system, work on system. This is a work on system. When you do work on the system, if you compress the gas, class, if you compress the gas, if you have a piston there and you compress the gas, you are actually adding energy into the internal energy, and the internal energy of the gas will increase, and then the temperature of the gas will increase. If you are able to compress the gas, class, if you are able to compress the gas, the temperature inside the gas will increase. Yeah, that's right. Don't believe me, class? First law of thermodynamics. Let's check the first law of thermodynamics, class. Yeah. Hold on a second. Okay. So let's say just the now let me write it down. Delta U equal to, let's say only have W. Wait. What's the formula again? Negative W, right? Negative W. Let's say no, we don't look at the Q. Yeah. Let's say no Q, just the W, just the work done. Okay. So work done on gas. What's the sign? If work done on gas, compression, work done on gas. If work done on gas compression, the work W is negative. Work done is negative, class. Negative. See? Look at here. I put negative sign. I put negative sign. So what is the delta U? Tell me, class. Delta U. Negative become? Class, tell me. Positive, isn't it? So this is let me write it down. W is negative. If work done on system, work done is negative. Work done on system, W is negative. That means you must put W as negative value. So negative, delta U is positive. What is mean by positive, class? I must, all this I must put it a bit down. Yeah, I must put it a bit down here. So that means this one is positive, this one negative, positive. So what is mean by delta U positive, class? The temperature, will the internal energy when work done on system, if you're able to compress the system, that means energy go into the system, energy go into the gas, just like the heat absorbed. Energy go into the system, energy go into the gas. So the internal energy of gas will increase, temperature will increase. If you're able to compress the gas, you actually energy enter. Now, if let's say, understand, class? Give me a thumbs up if you understand. If work done by system, that means if let's say the system do work. Now the system do work. Who do the work? Is it the system, the gas do the work, or the you or human do the work? Who do the work, class? The gas do the work. Class, if you do the work, you lose energy. Right or not? If the gas do the work, the gas expand, the gas push up the piston. That means gas lose energy. This is like, gas will loses energy. Gas loses what kind of energy? It loses internal energy. It loses internal energy by doing work. Because gas, who push the piston up? The gas push the piston up. The gas push up the piston. That means the gas do the work. If the gas do the work, dia hilang tenaga lah. It loses internal energy. That means it's like energy going out from the system. Means because work by who? Work done by system. Work done by system. So that means okay. Let me check the first law of thermodynamics. Yeah, let me check with this formula. Delta U equal to delta. Sorry, so many things. Yeah, delta U equal to, the formula is let's say no Q, only the negative W. Negative W. Now, to what sign do we put if work done by system? Work done by system is W positive. Work done by system is W positive. Expansion, work done positive. Put work done positive. Work done positive. So what will be the delta U, class? Negative positive, you get what? Negative. What is mean by negative? Delta U? Delta U negative means internal energy decrease, temperature decrease. See that, class? Internal energy decrease, temperature decrease. That means, class, if the gas do work done by the system, work done by the gas do work by pushing up the piston, expansion, volume increase. If the gas do any work, the gas lose energy. The gas lose internal energy. When the gas lose internal energy, the temperature of the gas will decrease. It become cold. Inside the container, inside the room, the temperature will decrease because the internal energy of the gas decrease. Why the gas internal energy decrease? Because it uses its own internal energy to do the work. Because it's work done by gas. Yeah, gas uses its own internal energy to do work. How you do work? He push up the piston and expand. So he lose energy lah. Imagine if you do the work, if you do work, you lose energy, isn't it? You can't say you do work and you gain energy. If you do work, you lose energy. Correct, not class? So if work done by system, you must put work done positive. Then you substitute W positive, negative multiply positive, you get delta U is negative. That means delta U negative means internal energy decrease, temperature decrease. So that's how it works, class. This is what we call first law of thermodynamics. Understand, class? Understand?
Understand.
Okay, let me just one question, yeah, just one question only for this one, yeah. 2:30 we will finish, yeah, and early. This book very beautiful, yeah, it's by my colleagues, yeah, who are good in all graphics and spend a lot of time. Okay, now let's do this work. Actually, it's not so difficult to understand the whole. It's not so difficult just to use a formula lah, yeah. You just need to remember, the sign convention. When is it positive? When is it negative? Okay, there's a simple way to remember, yeah. This one is more to explanation of the concept, yeah. Okay, let's do this question only, yeah. One question enough, okay, for today. So question 7, all right, question 7. So all right, my kids, I just went back from hospital, my kids sick, so for coughing for 1 month already, so many process, have to check for TB, everything, so just a lot of process lah. I need to go back hospital tomorrow and Monday also. So there's many, when you have commitments, all these things come in, yeah. Let's see. Okay, so you must understand your lecturer sometimes. Why not to say why lecturer they always escape class, yeah. No, they have problems. They have unseen problems that we cannot explain everything always, yeah. Okay, so now when the gas enclosed beneath the piston, yeah, it receives this amount of heat from the surrounding, and it also performs this amount of work in raising the piston. Determine the change in internal energy of the gas. By now you should understand what's happening. Yeah, it receive, the gas receive the heat. That means absorb heat from surrounding. That means the energy actually come in, right? Heat energy, yeah, inside the gas. Inside there is a gas, so there is a gas. Inside the gas has internal energy, isn't it? Has internal energy. Actually, it show here the Q. Never mind, just ignore it. Yeah, heat absorb, heat enter. Yeah, and then he also say the gas perform. Who do the work, class? Who do the work? Who perform this work, class? Who perform the work in raising, in pushing up the piston? Who do the work? Tell me. Who pushes up the piston? Is it the human or the gas?
The gas.
The gas. We call the gas the system. Understand? So the gas is the system. The gas do the work. The gas do the work. If the gas do work, or we can say work done by system, or work done by gas. Gas gain energy or lose energy? Tell me, class. If the gas do work done by gas, it lose energy or gain energy if the gas do the work? The gas get more energy or lose energy
Okay.
if the gas do work? Kalau kamu buat kerja, kamu jadi semakin bertenaga atau kamu jadi letih, kelas?
Lose energy.
Lose energy lah. Yeah, if you do work, you lose energy, isn't it? Gas loses energy. That means energy escape. Energy escape, yeah. Energy escape, yeah. Energy keluar. Work done keluar, work done. Okay. So energy keluar, ya. Energy masuk, energy keluar, ya. Kalau dia buat kerja, ya, perform energy. So this and ini maksud saya. Okay. So that means dia receive this amount and loses this amount. So what's the change in internal energy? That means dia tanya untuk apa? Dia tanya change of internal energy means delta U lah. Dia minta change of delta U kan. Okay lah kelas. Ini semua banyak konsep. Ya. So let me teach you a simple way to remember the positive and negative. Yeah. If you find it difficult to do. Yeah. Just review lah. Just review. Q bila dia positive kelas. That means when it absorb heat, right? Heat absorb, heat added, heat absorb or heat added. Yeah. When is it negative? Heat loss to surrounding. Yeah. Heat loss or heat heat loss lah. Heat loss. Yeah. Heat loss. Delta U, when is it positive? Positive, that means internal energy increase, temperature increase. Okay. When is it negative? Negative when internal energy decrease, temperature decrease. Okay. About the work done. Work done. So when is it positive, class? Positive when work done by the gas, right? Work done by gas or system. Work done by system. Okay. Work done by gas or work done by system. That means this is expansion, right? Not class. Expansion or volume increase. When is it negative, class? When is it negative? Work done on gas or work done on system. This is a compression. The volume will decrease. Okay, negative, work done negative. Okay. Very hard to remember this one, class. I know it's very hard to remember. Work done by gas is positive. Work done on gas is negative. Is it correct? I might check again. Work done on gas. Yeah, negative. Work done by gas is positive. Okay, very hard to remember. Okay, this way lah, class. If the gas got do work, positive lah. If the gas doesn't do any work, negative. Can you remember that way? Yeah, work done by gas. Gas got do work. Gas got do work. So positive lah. It's positive. This one. Gas not doing any work. Negative lah. Can remember like that, class? If the gas got do work means positive. If the gas not doing any work, negative. I think that's a easier way to remember. Yeah, gas not doing any work. Work done by someone else. Kalau kamu ada buat kerja rumah, positif lah. Kalau kamu tak buat kerja rumah, orang lain buat kerja untuk kamu, negatif lah. Okay lah. Macam tu lah. Kalau you ada buat kerja, if the gas work done by gas, the gas got do work, you got positive marks. If the gas Work done on gas, that means the gas does not do any work. Negatif lah. Ya. Maka negatif macam tu. Okay? Just a way to remember, ya. Okay, class. So okay, let's investigate. This one, it received this heat, right? Receive heat absorb, right? Heat absorb. So this one should be Q positive. Now, and then the gas perform this amount of work. That means the gas do work, isn't it, class? The gas got do work. So positive lah kan? Positive work lah. The gas ada buat kerja. Kalau you compress the piston, it means the gas does not do any work. The gas does not do any work. So negative lah. Negative. If the gas do work, means positive lah. Positive work done. Okay. Remember, like that. Enough. Okay. Delta U equal to, what's the formula? Negative Q minus W. So this one is positive. Q is positive. So this one must put positive value. So positive 2170 minus W. W is it performed this amount of work, you see. So work done, because gas got do work. Gas do work. So positive lah. Gas do work. Kalau kamu buat kerja, ada positive mark. Kalau kamu tak buat kerja rumah, negative mark. Begitulah. Gas got do work. Yeah. So gas work done by the gas. Yeah, work done by the gas. Get got do work. So positive. So ini tolak bukan negatif. Ini tolak memang sudah dalam equation. Ini tolak memang sudah equation. Work done sendiri itu. Work done itu sendiri positif 2840. Tapi kalau you tengok dia tolak, dia akan jadi, sebab ini tenaga, ini dapat positif, ini tolak, ini means dia akan hilang tenaga lebih banyak. Dia hilang tenaga lebih banyak daripada dia masuk. Faham tak? It loses energy more than it absorb. So that's why in the end you get negative. Your delta U, you get negative. You see that, class? You get negative. Negative what? Negative. Calculate for me, class. Calculate. 2840 minus 2170. What is the answer? What is the answer, class? What's the answer? Let me see the final answer. Yeah, over there. Let me see the answer. Question 1. No. Question 6, 7. Here. So question 7, negative 670. Negative 670. Negative 670 joule. That means what? That means internal energy decrease, temperature decrease. Negative means what? Negative delta U means what? Negative delta U means internal energy decrease, temperature decrease. That means heat absorbed less than the heat loss. Heat loss more than heat absorbed. That's why the internal energy will decrease. This one will decrease because heat loss is more over here. Heat absorbed is less over here. Heat absorbed is less. Heat loss is more. Yeah, heat loss is more. So heat loss is more compared to heat absorbed. You lost heat more. You lost energy more than you gain energy. You lost energy more than you gain energy. That means internal energy will drop lah. That's why you get delta U negative lah. Understand? It loses energy. It loses energy more than it gain. So it get negative. Understand, class? Understand? Okay. Thank you for your love, your thumbs up. Yeah. So that's all for today lah. Yeah. Sorry for taking so much time. I will post this video later on. Yeah. That's all lah. Okay. Let you have a rest. Yeah. Let you have a rest. So I'll continue next week. Good luck for your UPS, by the way. Your UPS 3, that's your only chance of getting better marks. Yeah, for UPS. Okay, thank you. Bye.
Thank you, sir.
Okay.